Hello, tech enthusiasts. I am Sucheta Gawade. Welcome to my session, Zero Trust Security with Microsoft Intune and Entra, which I am delivering as part of the Cyber Back to School 2024 event. Zero Trust is an essential security strategy in today's world, designed to strengthen enterprise security and protect against modern threats. It's a strategy where no user, device, or app is trusted by default. Everything is continuously verified before accessing corporate data. This is especially crucial with hybrid and remote work becoming the norm. Microsoft Intune, alongside Entra, plays a key role in securing devices, apps, and identities in a zero trust model. Let's dive into how to implement zero trust using these tools. Before heading to the main content, here's an introduction to the Cyber Back to School event of 2024. This year marks the inaugural year of this exciting initiative led by Captain Hyperscaler Dwayne Madwick. Be sure to explore all the valuable cyber content that is being shared as part of this event throughout October and stay ahead in security. Because while AI innovations are revolutionizing technology, security remains as a top priority for every organization worldwide. This is who I am, a Microsoft MVP in Azure and security, specifically Intune. I have over 16 years of experience working in large global IT environments. I currently work in healthcare IT in the US as the manager of an endpoint engineering team. I specialize in modern management and enterprise mobility, leveraging Azure and Endpoint Configuration Manager. I hold 15 certifications across various Microsoft Azure areas. My socials are listed here if you'd like to reach out for technical conversations. All right, here is the agenda. I'll begin by explaining what Zero Trust is and how it can be implemented across your organization. We'll explore how Intune, in combination with Entra, can help implement Zero Trust, focusing on securing and controlling devices and apps to align with key Zero Trust principles. Next, we'll dive into specific controls and capabilities, including device configuration, compliance, endpoint security, app protection, conditional access, and Defender for Endpoint, among others. Post that, I'll demo how to configure and deploy these settings in Intune to establish a zero trust security posture for your devices and apps. Finally, we'll conclude with key takeaways to reinforce actionable insights from the session. Let's dive in. The significance of zero trust is that it helps secure organizations in an era of increasing cyber attacks, remote work, and diverse devices accessing corporate data. But what is zero trust? It's a security strategy. It is not a product or service, but an approach in designing and implementing a set of security principles. The three key principles are verify explicitly, use least privilege, and assume breach. Verify explicitly means always authenticate and authorize using all available data points. Use least privilege access means restrict user access with just in time and just enough access. Implement adaptive risk based policies and data protection. And as part of implementing the third one, assume breach, we reduce blast radius by segmenting access. We ensure end to end encryption, and we leverage analytics for visibility, threat detection, and enhanced defenses. Rather than assuming that everything behind the corporate firewall is secure, the zero trust model operates on the assumption of a breach and verifies each request as if it came from an untrusted network. No matter where the request originates or which resource it seeks to access, zero trust reinforces the principle of never trust, always verify. Zero Trust verifies everything, including devices and apps. Next, let's look at how zero trust is implemented. A zero trust approach typically extends throughout the entire digital estate and serves as an integrated security philosophy and end-to-end strategy. You deploy zero trust principles across your IT infrastructure by implementing zero trust controls across 7 technology pillars as shown in the graphic. 6 of these pillars are critical resources to be defended. We apply security controls across them: identity, endpoints, data, apps, infrastructure, and network. These areas generate signals, improving visibility and providing better data to make informed trust decisions. Since each area generates its own alerts, we need an additional layer to collect and manage these signals. This layer is the visibility automation orchestration, which you notice at the top of the graphic. It spans all 6 pillars, gathers the signals, provides visibility into security incidents, and enables automation and orchestration to respond to and mitigate cybersecurity threats. Having this integrated capability is essential for detecting, investigating, remediating, and preventing threats across all 6 areas, while leveraging threat intelligence and known vulnerabilities to enhance enterprise security. From the various pillars we discussed for implementing zero trust, let's focus on the approach across endpoints, that is, devices and applications, while also touching upon identities. Using Intune in combination with Entra, we can apply specific configurations and settings to implement zero trust across these specific pillars. Together, Intune and Entra allow us to primarily focus on implementing zero trust for devices and apps. Managing devices and apps is a critical part of a zero trust security strategy. In today's mobile workforce, zero trust must adapt to the diversity of endpoints accessing corporate resources. Intune allows you to apply zero trust policies for devices as well as apps accessed on those devices. When an identity is granted access, data can flow to various endpoints like laptops, smartphones, and BYOD devices, increasing the attack surface. Intune helps centrally manage devices and apps to enforce policies, maintain device health, and ensure compliance for secure access. Intune protects access and data on both corporate and personal devices with compliance and reporting features that support zero trust. For applications, Intune enables controls to manage access, ensure secure configurations, and protect data at the application level. When implementing the Zero Trust framework for securing endpoints through Intune, we need to focus on some deployment objectives, specifically the ones that I'm bringing up here on the slide now. What you'll see are the individual controls and configurations within Intune that allow you to implement Zero Trust policies for your devices and apps, as they support the zero trust principles of verify explicitly, use least privilege, and assume breach. First up is registration and enrollment of devices. We do this to ensure we have visibility into all devices so as to monitor security and risk across them. Configuration profiles, specifically Hello for Business. Leverage configuration policies to enforce particular settings on devices. And what is encouraged here as part of Zero Trust is the use of a more secure Hello for Business login technique in place of traditional passwords. Then we have compliance policies that we need to implement to check and remediate compliance health of devices. Next up, device auto updates. This is done to help keep devices up to date with security and other updates, reducing vulnerabilities and hence the attack surface. What's next is endpoint security settings. These help safeguard devices by baselining security settings, enforcing encryption of data, least privilege access with endpoint privilege management, that is EPM, which helps manage and limit administrative privileges on endpoints, and managing local admin account passwords with LAPS, that is the local administrator password solution. Then we have app protection policies. These ensure that data remains safe or contained in a managed app that is protecting corporate data at the application level. And then we have the Intune Data Warehouse, which helps threat protection by enabling reporting on compliance and security and sending data to a SIEM. Defender for Endpoint. Its integration with Intune helps implement Zero Trust by providing real-time threat detection and remediation, enabling continuous verification of device security posture, and so on. And lastly, we have conditional access, which helps ensure that access to resources is granted or denied based on conditions we specify across endpoints and applications. In the upcoming slides, we'll take a closer look at each of these settings and capabilities within Intune to help configure Zero Trust in your environment. We begin with registering devices or joining devices to Entra and enrolling the devices into Intune for management. We do this because we need visibility into all the endpoints to monitor security and risk across them. Typically, after the devices are added to Entra and Intune, users are allowed to access restricted corporate resources on the devices using their corporate credentials. BYOD Windows devices and personal mobile phones, that is iOS and Android, are Entra registered. It allows limited management via application policies. In contrast, corporate-owned Windows devices are typically Entra joined or hybrid joined, allowing full management. We can use Windows Autopilot or Apple DEP to simplify device setup. Autopilot can automate Microsoft Entra join, enroll corporate Windows devices, and handle resetting or repurposing of devices. Similarly, Apple DEP allows for automatic enrollment of iOS and iPadOS devices into Intune. Corporate mobile devices are enrolled in Intune typically using Apple DEP or Android Enterprise in case of Android devices for full control. To manage devices in Intune, they must be enrolled, with admins deploying platform-specific enrollment profiles to enforce policies and configurations. Configuration profiles in Intune help enforce and apply specific settings across devices, such as Windows, macOS, iOS, and Android. They are primarily deployed on corporate-owned devices to manage security, compliance, and functionality. By applying these, we ensure that devices adhere to security standards. Example of configuration settings include controlling device password policies, restricting Bluetooth access on devices, allowing only specific apps, or locking devices into kiosk mode for specific single app or multi-app use cases. Configuration profiles vary by platform. Certain settings are unique to Windows, Android, or Apple devices. As part of a zero trust strategy, using Windows Hello for Business is highly recommended. It replaces traditional passwords with strong two-factor authentication on Windows PCs and provides authentication options such as PIN or biometrics, that is, fingerprint or facial recognition. Admins can configure and deploy Hello for Business via Intune configuration profiles and endpoint security account protection policies on Windows 10 or 11 devices. This aligns with the verify explicitly principle of Zero Trust. Device compliance policies also help enforce the zero trust principle of verify explicitly by ensuring that only compliant, cloud managed devices and apps are granted access to corporate resources. Compliance policies are rules or checks. With Intune, you can deploy compliance settings and enforce minimum security standards, such as require specific password policies on devices, require a minimum OS version, require that BYOD mobiles are not jailbroken, and so on. For BYOD devices, compliance policies also offer deployment of remediation steps that guide users to resolve non-compliance with their personal devices used for work. Admins can regularly monitor device compliance, identify potential risks, and take actions such as sending user notifications or remotely locking non-compliant devices. This ensures that the data they hold and the devices themselves remain secure as part of the zero trust strategy. Regular patching and updates for Windows, Android, and Apple devices ensure that the endpoints are up to date, secure, and compliant, and that devices are always protected from known vulnerabilities, which reduces the attack surface. Windows devices can be patched through Intune with the help of update rings or Windows Auto Patch, which uses Windows Update for Business and other service components to update devices. Windows Auto Patch helps automate the process of managing Windows updates, ensuring that feature updates, quality updates, and drivers are deployed in phases. For Apple and Android devices, admins can configure updates, allowing them to control when and how system updates apply to the devices. Admins can also configure and manage app updates on mobile devices. In the next few slides, starting with this one, let's delve into some specific settings that are configured through the endpoint security pane in Intune. As part of the Zero Trust framework, Intune allows us to enforce security baselines onto Windows 10-11 devices. Security baselines are collections of Microsoft recommended settings to enhance security. They provide best practices and a recommended security posture, ensuring adherence to Zero Trust principles like least privilege access by enforcing policies that limit user permissions and access rights. Security baselines also reinforce the verify explicitly principle by requiring devices to meet specific security standards, for instance, reinforcing password complexity and multi-factor authentication, combining with Entra capabilities. While Windows is designed to be secure by default, organizations may need granular control over security configurations. Security baselines help fulfill this requirement, allowing the baselines to be further customized based on organizational needs. From within the endpoint security pane, you can configure disk encryption settings to leverage the built-in BitLocker data protection feature of Windows devices and File Vault for macOS, that is Apple computers. You can configure policies for BitLocker or File Vault to automatically and silently encrypt devices to ensure sensitive information is protected, even if the device is lost or stolen. The policies also enable BitLocker for removable devices, removable drives, and require a password to unlock devices. BitLocker settings in Intune primarily support the verify explicitly principle of zero trust. BitLocker encrypts the device's data, ensuring that only authorized users and devices can access the data stored on the device. It provides strong protection for data at rest by requiring devices to meet encryption standards, which help ensure that users, devices, and credentials are validated before access is granted. Apart from the endpoint security section in Intune, Disk encryption settings can be configured via security baselines, as well as configuration profiles. Endpoint privilege management, that is EPM, in Intune supports the zero trust strategy by allowing users to operate as standard users without having to elevate permissions for certain tasks, ensuring least privilege access and reducing the risk of unauthorized access. It enables users to perform tasks that require elevated privileges, such as installing applications or updating drivers, without granting them full administrative rights. At a high level, admins can create and deploy elevation settings and elevation rules policies to manage privilege elevation in Intune. EPM enforces least privilege principles by elevating privileges only when necessary, and by verifying explicitly and limiting admin rights. EPM thus enhances security while maintaining user productivity. Windows Local Administrator Password Solution, that is LAPS, supports the implementation of Zero Trust principles by securing the local administrator account on Windows devices. It focuses on least privilege access. Since this account cannot be deleted and has full permissions, managing it effectively is critical for securing your organization. Through endpoint security account protection settings within Intune, you configure LAPS, which automatically manages and backs up the local administrator password. This ensures the password is regularly rotated and securely stored, preventing misuse or unauthorized high privilege access. Additionally, you can configure policies to manage members of the built-in local groups, such as the administrators group. By controlling membership of this group, you can restrict admin rights to specific members. Next up is app protection policies. Now, once access to apps and data is granted on devices, it's crucial to control what users can do with that data. As part of the Zero Trust strategy, data loss prevention, that is, DLP policies, are enforced on both corporate devices and BYOD. For example, you can restrict saving files to untrusted locations like local storage, or preventing sharing sensitive data through the chat apps. Now, app protection policies in Intune are key to configuring such safeguards. These policies allow admins to manage access to apps and ensure corporate data is protected or contained within managed apps, even on personal devices. App protection policies are often deployed in MAM, that is, mobile application management scenarios, typically for non-enrolled BYOD devices. However, app protection policies can also be applied in MDM, that is, mobile device management scenarios, for company-owned devices to provide enhanced app-level protection. These policies enable actions such as blocking copy and paste between apps, requiring a PIN to access protected apps, and preventing data backups to personal cloud services. Admins can wipe corporate data from devices that don't meet security standards, such as jailbroken devices or those with an outdated OS version. All of this without affecting the user's personal data. Next up is Intune Data Warehouse. It's a feature of Intune that provides access to detailed historical data related to device management and compliance over time. It allows to run detailed queries and generate reports based on the stored data. It is a powerful analytics tool that helps admins monitor and report on the performance, compliance, and security of devices managed through Intune, enabling better decision making and policy adjustments. Endpoint threat detection is used to monitor device risk. Using a single pane of glass, such as a SIEM, that is a security information and event management system, admins can route endpoint logs and transactions, reducing noise and generating fewer but more actionable alerts. The Intune data warehouse plays a crucial role in this by sending device and app management data to external tools like SIEM and Power BI, enabling centralized monitoring and real-time threat detection. This integration allows for consistent management across all endpoints and ensures that alerts are intelligently filtered for better visibility into security incidents. This setup helps organizations manage their threat landscape effectively while ensuring compliance and security across devices. Let's learn about the Microsoft Defender for Endpoint, that is MDE integration. With Intune, you can integrate MDE and other mobile threat defense systems to create policies that enhance endpoint protection. These services enable real-time risk analysis, automated threat responses, and remediation. This aligns with the assume breach principle of zero trust, where access control is based on endpoint risk for both corporate devices as well as BYOD. You can apply Defender app and configurations to devices, and then they communicate with MDE, providing data that helps assess their risk level. Defender actively scans devices for threats and identifies weaknesses through its threat and vulnerability management capabilities. It then shares this data with Intune. Intune can use this risk data for both reporting and enforcement. For instance, compliance policies can be set to define acceptable risk levels reported by MDE. Devices exceeding the allowed risk level are marked as non-compliant, and conditional access policies can be applied to block access to corporate resources from those devices. Let's learn about conditional access policies on the next slide. Conditional access is a core feature of Entra ID and Microsoft's Zero Trust security engine. It helps enforce the verify explicitly principle. These policies apply adaptive access controls to ensure only authorized users and compliant devices can access resources, thus keeping your organization secure. Conditional access uses if-then logic to grant or deny access based on specific conditions. For instance, if a user needs access to M365 apps, they must complete MFA. Organizations leverage conditional access to determine who can access resources under specific circumstances. The policies can be applied at device as well as app level. By combining compliance policies with conditional access, admins can enforce compliance. We can deny resource or app access on non-compliant devices that have an outdated OS or outdated application versions, for instance. Finally, by integrating tools like Intune, Defender for Endpoint, Defender for Cloud Apps with conditional access, organizations can deploy real-time monitoring and control over devices and apps based on user identity, device compliance, geographical location, and app-specific conditions. And with that, let's move on to the demo. In the demonstration, we'll explore the Intune portal to see how the settings and capabilities that we just discussed are configured to implement Zero Trust for both endpoints as well as apps. All right, I will start with accessing the Entra portal and navigate to Devices, All Devices. And you notice here, I have a couple devices that show up. A Windows device for which the join type is Entra joined. Such devices are generally corporate owned, as this type of enrollment is typically used to provide full management and access to corporate resources. And then I have an Android for Work device, which is a personally owned work profile device being used to access company resources. That is why it shows Entra registered. As we learned, we register or enroll devices into Entra and Intune for management, so we have the required visibility and control of those devices. Heading to the Intune portal, if I go ahead into Android enrollment, this is where you can find all the different enrollment methods for Android devices. You do need a managed Google Play account to start with. As for Apple devices, these are typically enrolled into Intune with ADE and ABM, and you have to create an enrollment program token. You do need Apple MDM push certificate to get started. And Windows devices are typically joined to the domain and enrolled in Intune that way. Windows Autopilot can help automate the process during enrollment. And then we have Windows Hello for Business, which is recommended as part of Zero Trust implementation. You can create Windows Hello for Business policy in Intune at device enrollment. You can also set up Windows Hello for Business after device enrollment through configuration profiles. If we create a new policy in here, select Windows 10 and later, templates, identity protection, give a test name, and this is where you'll create your settings for Windows Hello for Business if you were to configure devices with Hello for Business after enrollment. So that is Hello for Business, but configuration profiles in general help you deploy restrictions and features to devices. I have a few created here. There are numerous settings that you can push out to devices using configuration profiles. This profile, for instance, is one where I've added some Bluetooth settings for my Windows devices. If we head back to the main page, you can actually import ADMX and deploy GPOs as configuration profiles. With that, let's move to compliance policies. I have quite a few platform-specific compliance policies already in here. This one, for instance, is targeted to Windows devices. I'm specifying the minimum OS version that Windows devices must have in order to be compliant. At that, they're required to have BitLocker enabled. They're required to have Secure Boot enabled. This setting specifically integrates with Defender for Endpoint to evaluate and enforce compliance based on device's risk level. That's the Microsoft Defender for Endpoint setting. If Defender identifies a device's risk level as low or no risk, then the device will be marked as compliant, since I have set low as the compliance threshold. However, if Defender assesses the device's risk as medium or high, the device will be marked as non-compliant, because my compliance policy requires devices to have a risk level at or below low to meet compliance. And in a scenario where a device is non-compliant, then I'm marking it as non-compliant immediately and adding it to the retire list. Retire meaning removing all company data from the device. So those are my actions for non-compliance. However, I can also send out notifications to users to get them to make their BYOD devices compliant by, say, upgrading the OS in this example, if it is not Windows 10.x version that I'm specifying here. And this is where you would configure notifications for your end users. If I go back to policies, one other compliance policy I have in here is for Android, where I'm requiring that the phone must have a minimum OS version of 14.0. I'm marking the device non-compliant immediately if the device does not meet that OS version, and sending a push notification to the end user to have them upgrade their device. Now, the phone that this policy is deployed to, which is part of this Android dynamic group, is actually a device that does not meet that minimum OS version. If we go to groups, Android dynamic, and look for that particular device, you'll see that the OS version is not 14. It is below the threshold. So it shows non-compliant. If we go back, head to our devices view and go to Android, shows here non-compliant for that particular device. And then if you drill down into the device, into device compliance, you'll be given additional information for what exactly is non-compliant. And here you will know which policy it doesn't meet the compliance with. And then to understand the actual policy settings, you can drill down further and then find out that the minimum OS version for this device is what makes it non-compliant. Next up, let's look at device updates and patching controls. Now, these help ensure that your device remains secure, compliant, and up to date with the latest features and security updates. You can manage Windows device updates through this section. You can set up update rings to control how and when feature updates, quality updates, drivers are installed on your Windows devices. You can define deferral periods, deadlines, and configure automatic restarts for updates. The other more recommended approach or option is Windows Auto Patch. This service automates the process of managing Windows updates, ensuring that feature updates, quality updates, and drivers are applied in phases. You need to go to this section to be able to enable that for your use case. But if we head back to our original page, now I do have other platform specific updates to show you here. So exploring Apple first, admins can create policies and push OS updates and patches to iOS and iPad devices. You can select the version to install and can schedule to run at a particular time or opt for a couple other options. Then heading to Android, the text here specifically mentions that this relates to manufacturer-specific firmware updates. But for pushing updates to Android devices independent of the manufacturer, you set them up using a configuration profile. So under Devices, Android, you navigate to Configuration, and if we create one, select Android Enterprise, and Device Restrictions, give it a name. You'll see under General, we have System Update and a few different options to choose from for updating your Android devices. Now heading to another section, let's move over to Endpoint Security pane to review some of the controls available through here. And starting with security baselines, which is as part of Zero Trust, which is used to safeguard Windows devices by baselining the security settings. With these, you apply Microsoft recommended security configurations to enrolled, fully managed devices. Various baseline templates, as you see in here, are available. If you pick one, you can create a profile based on it and edit it to your liking. If I open this one, you can see that this offers several settings such as, say, device lock or Windows firewall or Wi-Fi settings with Microsoft recommended values for various settings. Admins can, however, modify the values and create and deploy their own baselines. If we move to the main page, here you will see that we do have some other templates available, such as security baselines for Edge or security baselines for Defender for Endpoint. Next up I have here is disk encryption. We can enforce encryption of data with the help of these settings for both Windows as well as Mac OS devices. You can specify the settings, for instance, require device encryption set to be enabled, or you can create configurations such as choosing your encryption method. If we head back to the main page and try and create a new policy, you can choose Mac OS and File Vault and then configure those settings accordingly by creating this particular policy. Next up, let me head to Endpoint Privilege Management. This is an Intune add-on, so it needs to be bought separately. However, in here you can create policies to enable users to perform certain tasks that require elevated privileges without granting them full admin rights. With these settings in place, users can run as a standard user and complete tasks that require elevated privileges. We first deploy an elevation settings policy that activates EPM on client devices, and then we deploy elevation rule settings, which link an application or task to an elevation action. So it's a combination of settings. Next up is Labs, which is part of account protection. And Labs is the local administrator password solution. It helps securely manage the local admin account on Windows devices. By configuring and deploying Labs policies, you can specify things such as whether you'd want password backed up to the on-premises Active Directory or in the cloud to Entra. You can specify the password age complexity and so on. I can show you some of those settings here. All right, so with that, I will return to the endpoint security pane to talk through a couple other controls shortly, but let's head to applications for a bit. Now, what's important to review here from a zero trust standpoint is application protection policies. These policies provide a robust way to secure corporate data at the application level on both BYOD and corporate-owned devices. In this policy that I've created for Android devices, I'm configuring data protection settings such as preventing backups, or if a user tries to save copies of organization data, I'm blocking that right here. I am restricting copy and paste between apps. And then I'm also performing certain settings in here for app bin and configuring that for applications. So these are typically the settings you would do for ensuring data loss prevention as far as your applications go. Then let's navigate to reports. In here, if you see, we have Intune Data Warehouse. With that Intune Data Warehouse, it gives you an OData feed, which is an API endpoint that allows to extract device management data for advanced reporting, analytics, and integration with SIEM tools. Next, let's review Defender for endpoint integration. I'm going to start with heading to the Defender portal, which is security.microsoft.com. And in here, if we go to Settings, Endpoints, scroll down, and this is where you would set your Microsoft Intune connection for Defender for Endpoint. To enable real-time risk analysis and leveraging the threat and vulnerability management capabilities of Defender for Endpoint, we integrate it with Intune. And on the Intune side, this is where you would configure additional settings for the integration. And once that is done, you would find that the connection status gets enabled. So that's the Defender for Endpoint integration with Intune. But then here we have EDR. This is where you would set up configs on the Intune side to onboard devices to MDE so that the devices start talking to MDE and MDE can monitor them for threats and risk levels. Upon onboarding devices to MDE, the built-in Defender antivirus on Windows devices is leveraged. And once Defender starts to monitor devices, you'll see data under the vulnerability management section. If we head here to Endpoints, Vulnerability Management, this is where you would see some of the recommended settings for your Windows devices and any other devices that you have integrated as part of MDE and Intune. Let's head back to the Intune portal and take a look at conditional access policies. These can be leveraged in combination with compliance policies and MDE to safeguard endpoints, apps, and data. As we've learned, conditional access policies help enforce compliance. For instance, if a device is flagged as non-compliant, we can use conditional access policy to block access to resources on that device. Also, if MDE tags a device as being high risk, then we can block access to corporate data on such a device with the help of conditional access. Conditional access is an Entra feature and can be accessed from the Azure portal, Entra portal, or Intune portal. We'll continue with it from within the Intune portal. Conditional access templates. These offer an easy way to deploy policies that follow Microsoft's best practices. In here, we find templates related to Zero Trust configurations. All these profiles that you see listed here help implement Zero Trust principles from within Intune. As an example, let's pick block access for unknown and unsupported device platforms. Now let's take a quick look at what this is supposed to do. So the way this is pre-configured is that excluding the current user, all other users accessing any cloud apps will be blocked or denied access. That is, if the device platform is anything but these, which are populated in the excluded device platforms list. In other terms, users will be granted access to cloud apps only on known and supported device types that are listed here: Android, iOS, Windows, Mac OS, Linux, and Windows Phone. Basically, for the exclusion, you'd select any platforms that your organization knowingly uses. And of course, you can edit it to your requirements by downloading the JSON format and modifying it. Then you can upload it back. You can hit review and create. And if you scroll up, you can see that you can make a few different modifications or changes in here to your liking. You can give it a name. And by default, you can see that it does create the policy in a report only state, and it excludes the current user. These are always the defaults when creating compliance policies, conditional access policies. And then if I hit create, it is going to create that profile for me. this first one right here. You can also create a conditional access policy from scratch without a template by starting a new policy right here. All right, so that concludes the demo. I will head back now to the presentation and proceed to talk through the key takeaways. Let's recap to wrap this up. In this session, you gained an understanding of the Zero Trust security model, focusing on how it secures organizations with implementation of three key principles: verify explicitly, use least privilege, and assume breach. We explored how Zero Trust principles are implemented using Intune in combination with Entra to protect your organization's devices and apps. You learned how to configure key controls like configuration profiles, compliance policies, endpoint security settings, app protection for both corporate and BYOD devices, and so on. Lastly, we covered how Intune integrates with Defender for Endpoint and Entra Conditional Access, providing advanced threat detection, enforcing security policies, and ensuring compliance. Everything supporting Zero Trust by protecting your organization's resources in real time. So, in effect, I believe this session gave you good insights into how you can effectively configure and manage Zero Trust policies to strengthen your organization's security for endpoints and apps by leveraging Intune. I hope you enjoyed this session. Thanks for watching and good luck. Happy learning.